In this section, we're going to start solving trigonometric equations. And when we solve for equations, we are finding values for x. In the previous section, we verified identities, where we wanted to make one side equal to the other, but our final answer still had x's in it. The two sides looked identical. Now what we're going to do is we're going to solve our equations, and we're going to find out what x equals, what angles give us answers for whatever we're looking for. So as a review from the last chapter, what is this expression asking me? The cosine of x equals 1/2. And as we talked about, when I'm trying to find an angle measurement, I'm finding the piece that is inside the trig function. So here, the cosine of x equals 1/2 is saying what angle measurement produces a cosine of 1/2. And what process do we use to find angle measurements? We use inverses, or in this specific case, the arc cosine, or cosine inverse. And we can get that from the calculator or the unit circle. Now, just as a reminder of what we did last chapter, what quadrants are the inverse functions defined in? And if we think back, we talked that sine inverse was defined in 1 and 4. The cosine inverse, or the arc cosine, was defined in 1 and 2, and tangent was 1 and 4. And the reason we had to do that was because when we took our inverse, we wanted them to be functions and not fail the vertical line test. With my normal sine, cosine, and tangent, they're defined in all 4 quadrants. But specifically for the inverses, we had to limit them. So if we solve cosine of x equals 1/2 from the unit circle, we want to look at the unit circle and say, what x values give me a cosine of 1/2? So what x values give me a cosine of 1/2? And I specifically want the angles. So cosine of 1/2 is positive, and we know cosine is positive in the first and the fourth quadrant. So if I look at the first quadrant, there's my x-coordinate that's 1/2, and down here's my x-coordinate that's positive 1/2 in the first and the fourth quadrant. So I can see that x is going to equal pi over 3, or 60 degrees, and x equals 5 pi over 3, or 300 degrees. Nothing new there. But if we use the calculator, we only get one answer. So I go to the calculator, and I say the cosine inverse of 0.5, and I get the 60 degrees. So from the calculator, we only get one answer. But I can clearly see from the unit circle, there's this 5 pi over 3, or 300 degrees as an answer, and I can't get that from the calculator. So what we have to do is we have to find the second angle ourselves using a reference triangle. So just a quick review on what a reference triangle is. Reference triangle, if I were to draw it out, looks like a bow tie. My reference triangle is going to be one of those 4 angle measurements. And when we're measuring, we're going in the counterclockwise direction. So what we know is that the calculator is going to give us this first answer, which we said is 60 degrees. The calculator does not give us the fourth quadrant answer because cosine inverse is not defined in the fourth quadrant. But we can find the fourth quadrant answer geometrically because we know cosine is positive in the first and the fourth quadrant. So I'm going to draw a reference triangle in the fourth quadrant. And remember, reference triangles are always based off of the x-axis. So in this case, if I'm basing this off the x-axis, I've got a reference triangle. This angle is also going to be 60 degrees. Whenever we have a reference triangle, all our angles are congruent. And now if I want to find the total measure of the angles, remember we go in a counterclockwise direction, so there's my 60 degrees. I need to go around here in order to get this angle. And that angle, we know, is going to be 360 minus 60. Since I'm based off the x-axis, I know this is going to be 360 degrees, and I'm going to subtract this angle measurement to figure out the distance there, which is the 300 degrees. So in this section, what we're going to be doing when we can't go to the unit circle is we're going to be creating a reference triangle and then either adding or subtracting from different angle measurements to find what the actual angle is going to be. It's not always going to be subtracting from 360. Because let's say I had a reference triangle, and let's say this angle ended up being 20 degrees. And then I found that my other reference triangle was going to be in the third quadrant. I would know that this reference triangle is also going to be 20 degrees. And if I'm finding my angle going around in this counterclockwise direction, I know this is 180 degrees. This is 20 degrees past it. So in that case, I would be adding 20 to 180. I might have a reference triangle that is in the first quadrant, and let's say this is 30 degrees, and it would be in the second quadrant. If that's the case, once again we go in a counterclockwise direction, and I want to find that angle measurement. Since I know this is 180 degrees, I'm going to subtract 30 degrees to give me that angle measurement that's in the second quadrant. So what we're going to be doing is we're going to be drawing all these reference triangles and then either adding or subtracting from 180 or from 360. So we've got to recognize what triangle our reference triangle is in, or what quadrant our reference triangle is in, and then we're going to add or subtract the appropriate amount from the axis that we're closest to. So in your mind, you can't think I'm always going to subtract from 360 or I'm always going to subtract from 180. It's going to be based off of which quadrant my angle is in. I'm going to have to think about that algebraically. And that's what we run into when we don't have answers on the unit circle. So going back to the ones that we do have on the unit circle, from the unit circle, solve the following on the interval from 0 to 2 pi. So the sine of x is equal to square root of 2 over 2. I want to find the sine values that are positive square root of 2 over 2. Since I'm looking at sine, I'm looking at the y values. So where my y is positive, or where is sine positive, well, it'll be the first and the second quadrant. And I see the y value is square root of 2 over 2 at pi over 4 and 3 pi over 4. So this equation, if I solve for x, is going to be pi over 4 and 3 pi over 4. The tangent of x equals negative square root of 3 over 3. Now, if I look at my unit circle, I don't see tangent values on there. So I've got to do a little bit of math. And this one I can see is going to be negative. So I'm going to be in the second and the fourth quadrant. So second and the fourth quadrant. Remember, tangent is y divided by x. So I've got to take my y's divided by my x's for each of my ordered pairs. And since this answer has a square root of 3 in it, I can limit myself to one of these two ordered pairs, y divided by x. And in this case, the y divided by x that's going to work is this one right here. The negative square root of 3 over 2 and 1/2, which is going to be 5 pi over 6. So the first answer is going to be 5 pi over 6. And where we get that is because tangent is not directly on the unit circle, it's y divided by x. 1/2 divided by negative square root of 3 over 2 is negative square root of 3 over 3, which is what we're looking for. And then the angle measurement, that's the same in the fourth quadrant. When I take 1/2, or the negative 1/2, divided by square root of 3 over 2, that also gives me a negative square root of 3 over 3. So my two answers for the tangent is going to be 5 pi over 6 and 11 pi over 6.